What is a prism? A prism is a geometric shape that's kind of pulled through space. We're most accustomed to seeing rectangular prisms. So looking at this picture right here, we have a rectangle, and this rectangle is like pulled through space. It has a depth to it as well. And so we talk about a base and a height of these shapes. For another example, this one is a triangular prism. I can tell because the base shape is a triangle, and then this triangle is pulled through space, so it has a height. There's this octagon, and this octagon, that octagon is the base shape, and it's pulled through space. So this is an octagonal prism. This is a triangular prism. This is a rectangular prism. And so what we're doing in this section is we're talking about the surface area of these shapes, the lateral surface area, and also the volume of these shapes. Lateral surface area is the area of all sides, but not the top or bottom. So lateral surface area might be in that area too. So those four sides, but not the top or the bottom of the shape. Lateral surface area of this triangular prism would be the area of this rectangle here, that rectangle there, and also the rectangle on the back, but not the top or bottom. This is different from the total surface area, which is the surface area of all of the sides. We also talk about volume. Volume is the area of the base times the height. So with some of these shapes, it's really important to realize or to figure out what the base is. The base is the base shape of the figure. So for example, even though this shape has rectangles on it and triangles, I know it's a triangular prism and the base is that triangle. The name of the polygon used as the base names the type of prism. So this is a triangular prism because the base is a triangle. This is important to realize that even if this was laying on its side, the base doesn't mean the bottom. The base means that fundamental shape. The base is still a triangle. This is a pentagonal prism. And again, even if we knock that over, kaboom, that would still be a pentagon for the base. So the volume of a prism is the area of a base times the height of the object. Let's find the lateral surface area of this triangular right prism. Lateral surface area is the area of all of the sides. So I'm going to call this area 1. I'm going to call this face area 2. And then area 3 would be on the back there. We're just going to find those three areas and add them together to find the lateral surface area. So for area 1, I see that this rectangle, because that's the shape, even though this is a triangular prism, that shape is a rectangle. This rectangle has a base of 12.0 centimeters. It also has a height of 12.0 centimeters. I know that label is over there, but this height is the same as this height. 12 times 12 is 144. For the area of rectangle 2, I see it has a width of 5 and a height of 12, so that area is 60. And for area 3, I wish I could pick this up and turn it around to show you. We have a base here. We don't know the length of it right away, and then we have a height of 12. So what we're going to do to figure out this third area is we need to figure out the hypotenuse of that right triangle. We can figure out the hypotenuse using the Pythagorean theorem, which I'm not going to go through right here, but essentially it's going to be 12 squared plus 5 squared equals that hypotenuse squared, and it works out to make the hypotenuse 13. So that means the base is 13 and the height is 12. 13 times 12 is 156. And now we can just add these together. 360. So 360 square centimeters is the lateral surface area. Now let's do a problem about volume. A rectangular swimming pool is 20 feet wide and 40 feet long. The bottom slopes evenly from the shallow end, which is 3 feet deep, to the deep end, which is 6 feet deep. What is the volume of water needed to fill the pool? So essentially, what's the volume of this shape right here? And notice it's not drawn to scale. I see that I have a shape of a trapezoid. So this trapezoid has 3 for one base, 6 for another, and then this height between the two, because those are right angles, the height is 40 feet. So we're not used to trapezoids oriented this way. We're used to them being more up and down, like that, but it's the same idea. So the area of the trapezoid is the average of the two bases times the height, the distance between them. So 3 plus 6 divided by 2 works out to be 4.5, so 9 halves. So the area of that base right there, the area of that trapezoid, is 4.5 times the height, which is 40, or the distance between those two sides. But we want to find the volume. So this is the area of the base. And so to find the volume, we want the area of the base times the depth of that object, or height of that object. And in this case, that height is that distance right there. So that's 20 feet in this problem. So the volume equals 4.5 times 40 times 20. Multiplying that all together, we end up with 3,600. Since this is a volume, that is feet cubed.